Let's relate impulse and the momentum, change in momentum. We start with Newton's second law. This is the Newton's second law. F is equals to ma. So here, summation F represents the total force acting on the system. This m represents the mass, and here a represents the acceleration. Okay. For simplicity, say for simplicity, let's take this example. This is the floor or ground. Say this object has a mass m. We are applying a push force, push parallel to the x-axis. Say this force is F, just one force here, applied external force. Say at this point, we can assume it has this initial velocity Pi. Because of this push force, it will move forward, and say after some time it will be here. So this final velocity is Pf. So we can say the time interval to change the initial velocity Pi to Vf is just t. Okay. In this case, we can write Newton's second law as F equals ma, because we have just one external force over here. So this can be written as F equals a. By the definition of acceleration, this will be V final minus V initial over time interval t. I will multiply both sides by t. So this t cancel out. So I got F times t equals m times P final minus m times P initial. I can write this as F times t, that equals P final minus P initial. So here P final equals m times P final is the final momentum, and Pi equals m times Pi, that represents the initial momentum. Okay. So this can be written as Ft, F times t, that equals, this is the change in momentum, so we can represent delta P. Okay. In general, we can write this equation as F net, if there is more than one force, one external force, time interval is the delta t, that equals change in momentum. Okay, I use this to match with the book. So here F net is the total force. So this gives the idea that F net times t, which is F times t here, this we call it impulse. Okay, product of force, net force times time interval is called the impulse. So we got the idea from here that impulse equals change in momentum. So we can write change in linear momentum. So this is not a new concept. This actually came from Newton's second law. So actually from Newton's second law. which is net force equals m times A. So from here, we can say the unit of impulse or change in momentum, equals Newton second, because force impulse is the product of force and the time interval. So Newton second or kilogram meter per second. Okay. Based on that, we can solve a problem here. So here, the car has a mass. Initial velocity is 5.5. So you can draw a sketch like that. Say this is, say, for example, this is a ground level. Okay. So we can assume initially the car is here. It has initial velocity vi. Because of this force, which actually brings the car at rest, say v final is equal to 0 because it stops. So this will be 0 meter per second. Our goal is to find time interval to get a stop. Okay. So at first we can use Newton's second law, which is A equals net force over mass. So based on given information, this will be 1600 over mass of the car, which is 15,500 kilogram. That gives me 0.1 meter per second square. Okay. So this from Newton's second law. Our goal is to find the time, so I can use one of the kinematic equation, which is P final equals V initial plus A times T. My V final is equal to 0, V initial is 5.5 plus my acceleration is 0.1 times T. So here, one important thing we need to consider is that the acceleration is negative because the object is actually slowing down. You can see it is slowing down. Okay. That's the reason. It's minus here. Then I can do some algebra like that. Minus 5.5 minus 5.5. It will cancel out. Minus 5.5 equals minus 0.1. 0.1 divided by times t. Then I will divide both sides by negative 0.1, negative 0.1. That gives me, that basically gives me t equals 55 seconds. Okay. So based on that, or similar problem, one of the similar problem, you can practice this. It's very similar. Please, you have to try it. Okay.